I figured no one was watching. Now that I got that all messed up, let's go back to this project. I want to see how this coil resonates. I really wonder why this thing blew up. There's not much on here that can go bad, really. But if the bridge rectifier ties right into this guy, I bet this guy's bad. I'm gonna pull it off there real quick while I can. I don't know how to check it. I don't even know what it really is. But it's probably bad. The bridge rectifier that I cut off here, that I thought was bad, probably should be put back on. I think it's in there. Yeah. I'll have to solder it back on, I guess. What blew up? The driver. I don't know, the trace blew off of it. But I think it... There's a wire connecting the negative side to this, and it actually blew the trace off the back side of the board. I thought the bridge rectifier was bad, but I think it's okay. See if I can find this chip. A gate bipolar transistor. Isolated gate bipolar transistor. A GT60N 321. I'd like to buy one. Oh, they don't cost nothing. $1.84 on eBay. Let's see if we can figure out how to check it. Because if it's the only thing wrong, that'd be cool. So it's got a diode across it. 1,000 volts. 60 amps. One millisecond it can go up to 120 amps. So, from a collector to emitter, there's a diode. So, between this guy and this guy, 50 ohms. .1 ohms across. Oh wait. Yeah. Shorted out. So we might be in luck. We might be able to fix this after all. I guess I'm gonna order one for $1 something, free shipping. Wait till it gets here. The bridge rectifier seems fine. I checked it. And basically, if you follow the circuit back, except for that inductor there, it's basically a dead short. I don't know why it would pop on the AC side. Very weird. GT 60 N 321. Steve says you better get two. Like $1.84. It's pretty cheap. If these are used in TVs, which they might be, I might even have some on there, but alright. I'm just gonna I'll buy a bridge rectifier as well. I don't remember what the name was. Alright, from China, from Germany. Dang, they want $16 for that guy. China. Yeah, I guess we'll order it from China. Otherwise it's going to cost me 12 bucks. $2.50 for shipping. I'd rather buy one or two and wait forever. Yeah, I had it cranked up. I mean, what did we determine the bridge rectifier was rated at? 20 amps, we said? That's insane. Alright, sort lowest price plus shipping. Alright, we'll get the transistor. We'll get the exact same one. Oh, November 4th delivery. That's not bad. I'm going to order 3 because they're $1.70. And then let's see if I can find this bridge rectifier, even though I think this one's okay. I don't know if I have any this high amperage. I kind of looked. I think the one I had was lower amperage. Let's see how much they cost. Ooh, they're expensive. Oh, 5 pieces for $6.20. So for 5 of them, it'll cost me 6, 7, 8, almost 10 bucks. Let me check it again, because I think it's okay. I just have to rewire it. I should have unsoldered it. Instead, I cut it off. I thought for sure it was bad. So let's see, from the positive side, it looks good. On the negative side, it looks good. Yeah, it's okay. It's perfectly fine. So I'm not gonna buy one. I will just fix her up with some heavy duty wires, clamp it back on the heatsink. So we'll buy 3 of the transistors. It's gonna cost me $7.70. I'll order 4. Even though I don't know if it's good or bad. Check out. GT60N 320. GT60N 321. That's what it is. Oh, November 4th through the 27th. So sometime next week. That's fine. And then we'll fix this guy up. But for now, I'm going to unsolder it from the circuit because I want to see if I can get it resonating. Thanks, your order was placed. Alright. I think it's worth it if the driver still works. Actually, I should put the bridge rectifier back in it. And I better not power it back up, though it might blow up or something. it is a dead short though across it, so I think that'll fix us up. This driver is pretty well indestructible, so if that's the first thing that popped, that's a pretty good deal. It was pretty abusive. I'll agree with you. I might be able to get this to work better too if I redo something a little different, but what I want to do is actually see if I can tune this a little better. Alright, so the ohmic resistance across this coil it's a negative resistance. Did you see that? There's 0 with the leads. What? I'm confused. I've never in my life seen a negative resistance. It's a real negative resistor. I'll have to take a picture of that. Oh, there it went to 0. That is bizarre. Maybe it's because it was heated? I don't know. Oh, you know what? I kind of wonder if there's actually a short in this coil and that's what did it. It might just be shorted right there. Because those are the only two places where the coil is touching. That is hilarious. You guys see that? It went to a negative resistance. That's hilarious. Let's pop this off. I'm pretty sure. I mean, the wire looks amazing right there. I'm pretty sure. I thought it was a higher resistance than that, but. I'm waiting for 2 things in the mail now. Both from China. I mean, this is already a short, so it like literally can't be any worse. Alright, so I'm going to leave these shorted. And these are connected 2 sets, so that's what I want. Let's set this driver over. I'll just set it there. Okay. And this guy's ready to get fired up. And I basically just want to measure the output of this one. Before I do that, I think I will slip on some heat shrink over this. I gotta be careful cutting these. Scraping up the wire, man, ain't no good. I guess I could just rewrap it, but alright, I'm gonna slip on some heat shrink to protect the coil, and then I'll put the zip tie back on there. Whoa. Like that. Should put the zip tie back on it though. Maybe just twist them together, I guess, is okay too. Okay, that's alright with me. Let me slip some more on maybe. So what's interesting is that the plasma that was being generated, it was actually being generated on the primary side of this circuit. Which means it's pushing out an electrostatic field, I think. Are you guys still in the chat? Because it's either A, not updating, or B, you guys just ain't talking. Alright, so I want to see the output on this coil. So let's go ahead and just well, we need to connect. Oh, you guys are here, okay. We need to connect, they're already there. So we are going to connect this because we want it to resonate. So let's go ahead and connect that one. We want it to resonate similar frequency. I may need to tune it by moving these around. Actually, I can do that manually. That's kind of fun. I don't have these marked. The other ones had red and or black, but we'll just see how that goes. Okay, turn on our equipment. So what I'm looking for, oh yeah, and I was going to connect the Stillwell, the bridge rectifier, and we'll just check our charge on this cap. So that's what we'll look for. Okay, so I'll put those back, put these big jumpers on here. So the primary coil is open. It does not have a capacitor on the secondary. That coil is just open. Set our amplifier. Man, I really hope I can fix that driver. That thing is robust, but it took some ridiculous abuse, that's for sure. I need to tune the frequency though, I think. Alright, 1 voltage peak to peak, 0 offset. We're going to put it at 22.8 kilohertz. The amplifier is turned down. This probe can just be clamped here maybe. and we will see if she resonates. Oh yeah. Alright. Oh, there it is, it's charging. I gotta pay attention to that. So let's tune it. Oh yeah. So that's on the second coil. It's pretty good. Let's try connecting it to the short. I'm curious if it. Here it is, it's charging on there too. Okay. So what if I disconnect or switch that? Okay, so these are the right sides, so like that. If I clamp it, it's skyrocketing. Now let's see if I move it away. Or if I turn it. So it is directional, right? How about sitting this way? So they are coupled closer than I remember. However, let's try tuning this, because this is out of tune. Doesn't really change anything. What if we... Oh, it's not on top of it either. Let's put it back on top. Let's see if... Oh yeah. That definitely... There we go. Ooh. Oh, that's on the other side. I was gonna say, what was that happening? But I coupled it to the wrong one. Just looking at the scope. That seems like a pretty good one. Alright, well, let's try this. Let's try changing the frequency and see if we can drive the second coil. There we go. Oh, it's arcing. That's intense. The second one is hissing. I'm going to turn off the lights again because I cannot tell what is going on. Oh snap. What the heck? I must have a... You see it lighting up? You can see it. I'm going to take a picture or a video of that. Alright, so the rodent coils here, you can see them next to each other. I'm just going to bring them close to each other, and there's a nice arc going on one of the wires. Let's hold it back here. There you go. No, that's not a great thing. It's right next to the plastic. I think it's trying to burn the plastic. Ow. So, anyway, I think we have a short in our winding. That's half the battle of why I blew up my driver, probably. Maybe not. Alright, well, let's try this. On the second half, I'm going to add another set of caps. Well, I only have one. Oh well, we'll just take this one off for now. So we'll drive this one. And I'll take this off so there's no connection there. Oh, I need that one. That one, okay. Yeah, you can see the glow. Alright, let's see. So we don't get charging. It's not resonating. Let's tune the frequency. My caps are getting slightly warm. So we do need the caps in order for this to light up. That or I got a wire wrong. Maybe I had the wire wrong. Oh yeah, look at that skyrocketing. It's strange that it's doing so well even with that short. I should find me a load for that power supply. Go get that fan. Because what I want to know is how they couple. So I gotta get them pretty close. And if I take off the cap, they don't really have that effect. If I add the cap, charge up like crazy. So it is like resonantly coupled, but the difference is the frequency. How do I tune? I guess I gotta tune the second one by caps. However, it doesn't really seem to make a difference. I don't see any. Well, its couple's not coiled either. Let's put it back on top. Oh, it's still charging. Obviously, if I connect the caps, it's even better. Because see, this has a different size wire on it, so it's going to ring at a different frequency. That's pretty good right there. The other thing I can do is lower the 300 volts are going to blow up this power supply. Yeah, see, no caps is no good. One cap is okay for driving power out of it. I guess because it okay, so let's try adding another pair of caps. I got one more row. Make sure these aren't getting too hot. Ah, they're cold. So this will add the last row, because I may need even more capacity. Oh yeah, that's a lot better. Or is it? Nope, it actually is not better. Let me go get the little fan. Do I even have one here? I may have a... Here, let's just hook it up to this circuit. This little fan will at least run some of the power down. So we'll just go to ground. Ground. And then from 12 volt fan to 12 volt power. And at least pull it down a little bit. So let's hook it up. There it goes. Okay, we're gonna have to go get a a bigger load. You know what I can do? They're not 12 volts, but if I had a light bulb, oh, plastic between it. I just don't have any good 12 volt devices out here. What about just a coil? I can do that. Here, this is a 24 volt DC coil, so it'll pull half the current. Let's see what happens when it kicks on. Oh, it's just climbing past. It says the heck with you. Oh, why don't I guess I could try charging a battery. Okay. That I can do. Let's see if one of these is lower than the rest. That's actually a good idea. This is something I need to do anyway. So I'm actually charging this off the second rodent coil, which is kind of interesting. Alright, that one's at 12.6. That one's at 12.9. I need to charge these anyway, so hey. Alright, so here's the battery voltage. I don't know if you'll be able to read it. Oh, that one's like dead. So let's try charging the dead one. Good idea, Russ. Here, let's get the power supply back on and we'll check and make sure that it doesn't blow up anything. Alright. You can kind of see stuff. Let's just see what happens here. It should pull it down. I mean, it's just going way past. Maybe it doesn't. Maybe it's sulfated so bad that it's actually doing a bad thing. Okay, well, darn. That battery is apparently pretty dead. These two are still good. I guess I could just start adding coils, but I want to check the amperage, so let's do that. Let's check the amperage on the output. I'm not driving it very high, so it's coupled really well, considering it's charging better than the output of the coil on the other side, so that's kind of weird. Alright, I'll put it on amps, put it on 10 amps. There's the amperage. We'll go from the negative like that, and we'll go across some coils. We'll just start, I guess we'll just start adding coils. These are 24 volt coils. I don't know if I got any 12 volt. Let's see, they're all 24 volts. I guess if I double them up like that, then they should be technically half. Alright, so we got the amperage, so let's turn it back on, see what the amperage draw is. So last time we got about an amp out of the system. Here we got about 0.61 of an amp, so let's add another set of coils. I'm going to add 2 more of those. Let's just add these. So these will be in parallel. Parallel these up. Okay, there's one more. Kick it on. See how many amps. 0.74. So I'll add. That didn't add much of a load at all. Oh, that's a 120 coil. I have a few of those, apparently. That was one of them. Alright, hook this back up now. Now we got it across the 24 volt coil. 0.82. Now we slowed the charge rate down pretty good. So let's add one more. And this should get us close to the amperage rating that we're kind of looking for. There we go. We're at, oh man, it's still climbing. We're at about an amp. So last time the fan drew about an amp. So let's hook up, here's another one of these. These are lower resistance. Let's see, I'll connect this is just the voltage of the supply. That's helpful. Because it actually drops. Okay, so we're going to connect yet another coil. This one has lower resistance, it should draw more. It's looking like a bit of a monster over here. Okay, ready? Meter on. Charge. Go! Alright, now it pulled it down. Excellent. So now what I want to do is see if by changing capacitance any of these are better than the other. Still going up. Still going up. How about just one? One is no good. Two is okay. Three is not bad. 4 is better. 5 is better. 6 is good. 7 is good. 8 is better. 9 is better. Okay, so actually let's actually add another bank and see if we can get it to climb, because it may need even more to get even closer to resonance. Oh yeah, that's even better. That's even better. That's even better. That's even better. Let's go to the max. Oh yeah, look at that. So let's see if it slows down once we get to our, yeah, it's pretty good there. So we're at 1.2 of an amp. And if I turn the volume up, I can probably get more out of it. So I'm actually tuning it with that. So what does that tell me? It tells me I probably need to drop down to the lower frequency and add more caps to the second coil. So let's try that. So let's pull off this guy. We're just going to go to one set of caps, which means they get hotter. And we'll save the other bank for the other coil. And now I need to go find resonance again. Whew, look at that shooting up there. Wait till it kicks on. Pull it back down. So I'm just gonna It's right in here. I'm going to try tuning it. There, it's going back up. So it seems to be, the secondary seems to be tuned right there, but if I change this to like here, we're even closer actually. So now we're at the lower frequency, so we can do that better. Oh wow, now that I look at it, my voltage really isn't even turned up that high. Look at that. Now we're going past. Alright, so what does that mean? That means we are much better coupled than what we were before. This is way better than last time. Like last time I came out here and messed with this, I mean. Last time I could only get just above an amp, and that was with that coil on that side. Here I'm about an inch away from this other coil. And it's not omnidirectional. Be careful. My probe is trying to kill itself there. What happened? Did I kill it? Might have. Oh no, I just turned it down, that's all. Okay, that's the output. Okay. So it's pretty good pulling an amp and a third. Something I really want to do, I really want to put the watt meter on there. So let's do it. Let's just put the watt meter on there and see where we're at. Really, well, that one I blew up. I really need an extension cord. And these caps are getting hot, aren't they? You can. Ow, damn it! Thought that shocked the piss out of me. Okay, this is gonna be fun. I don't know which cord goes where. So someone do the math. Let's see. I can sustain. Steve, you still there? Are you gonna do the math? So we're right there. We can hold steady, and we have 1.23 amps at 12.28 volts DC. So this is the DC output. So what is that? I'm going to turn it down. Actually, I'm going to turn it off, and I'm going to try to find the cord that goes to the amp. I never once blown a fuse on the amp. I remember 007 was blowing them all up. be on the other side. Is that it? No. Must be over here. Yeah, right there. Okay. Now this one. This is going to be fun. So lots of cords back here. Just curious of like what the whole amp is pulling, because that will answer a question or two. Okay, that's the cord for that. Should be the cord for that. Ow. Alrighty. So that's that. Plug it into here. And I don't have good grounding, but I do have this cord, and we'll just use it. 15 watts. Well, I'm sure I'm driving it at more than that, but let's find out. I could add a bunch more outputs on this coils too, though. That's what I think I need to do, is just keep adding outputs. It's alive! Alright. Power factor 1. What? Oh, it's not on either. Hertz, volt amps, watts. Amp on. Alright, so it pulls somewhere around 12.7 watts, 12.6 watts with it off. 12.6. So let's turn it on here and see how many amps, so many watts it pulls. It should be somewhere around 60 something. So 8, so 7, 72-ish, that's about right. So, let's try hooking up this second bridge rectifier. Just don't forget, that's on the secondary coil, not even on the other one. So let's go with this guy. So positive and negative. I'll hook this guy to this output of this coil. Now, probably gonna have to hook it up to another cap. Or retune it. Let's try retuning it first. There we go. Oh yeah. Swung right past it. So there, now we're driving it with... Oh, it's using more power now. Oh boy, I gotta turn that down. So now I can drive it really far, still pulling the same amount of watts. So let's try adding a cat bank and see if it boosts the output or if it stays the same. Alright, so we'll just add this guy. Now it's back down to a little bit lower wattage. Alright, boop. Oh, I actually killed it. So now, oh, the wattage dropped way down. So let's retune. Now we're going back up. A lot of different tuning variables in here for sure. I hear the coil buzzing. Alright, well that's actually strangely not beneficial. It's actually better to have it open. Okay, now we'll retune it. Look at that. Shooting up. I think it must throw it off. Okay, 1 volt times 1 is 1 watt. Do you have an oscilloscope on both coil secondaries? No. And I'm just got it on the wire. I'm not actually touching the actual circuit. It's 10:30. I gotta go. Dang thing is just shooting out plasma out the side of that coil. Stop it. So this watt meter says it's pulling about 106 watts total power to the amp. My measurements to the coils was always around 65 watts max. True power, of course. But that's it right there. We're maxed out of the thing. What if I connect? Let's do this one more thing. I'm gonna connect these coils. These are another set of coils to the output of a bridge rectifier. Ooh, that bridge rectifier is hot. These bridge rectifiers are very inefficient too. So now we're going up even more. Let's try. Yeah, it's pretty well on frequency. 16.4. That's about the right frequency. I'm surprised at how hot. Yeah, those bridge rectifiers are hot. They're probably burning half my power. Need to get some high power, high frequency. The 16 kilohertz going into those bridge rectifiers. So there you go. Now I got a watt meter for that guy. That's kind of nice. Alright, I must go to bed. Thanks for hanging out. See you tomorrow. I don't know if I'm making headway at work, but you never know until you try, I guess. Alright, it's been a good exploratory day. Except for my pulse motor build-off thing that I ruined. Oh, and I have an amplifier at work that I might be able to run off 12 volt. So I'm gonna bring it. In. Bring it home. So I forgot to grab it today. So remind me tomorrow to grab that amp. It's a little amp that I should be able to run at the higher frequency. I think I can run it up to my 50 kilohertz, which is what I want to do. This big amp don't do that. So remind me tomorrow to do that. Thanks for hanging out, guys. Appreciate it. See you tomorrow. I will see you tomorrow.